finishing class 26 today. We're also going to do class 27, but 27 will not be on the test. Okay? And the next class we have, Tuesday of next week, is going to be our review / test 2 day. Okay? So test 2 will be on lessons 14 through 26. Everything that was on quest 3, everything that was on quest 4, plus one more lesson, class 26. 25 quadratic models. Yeah, we're going to do some more quadratic models today with 26. Yeah. Yeah. Everything from quest 3 and quest 4 and class 26. So one more lesson, and we're going to do some of that today, class 26. Okay, so just to remind you, this was class 26. It was graphing parabolas and problem solving, which involved some quadratic modeling. So we did another method of graphing parabolas, right? And that was almost exactly the same. The only difference was that instead of averaging the x values to get the x coordinate of the vertex, now we can find them by doing negative b over 2a. Okay. So it's just everything else is the same. Just another way of finding the x coordinate of the vertex. All right, so all right, so I'm going to do one of the problems from the class 26 activities with you, because this is where we left off last time I saw you. We did the class 26 demo, and we didn't really have time to start the activities. So maybe I'll do the first two with you, page 204. All right, so a rock is thrown upward. Its height, h, in feet after t seconds is given by this equation. H is negative 16t squared plus 12t. So t is just how long after you threw it, and then it calculates h, the height of the rock. I want to find the maximum height of the rock and the number of seconds it takes to reach its maximum height. Maximum, right? That's a word like largest, maximum, biggest, those things, or if you said minimum or smallest, those words all mean, when we're dealing with a parabola, those words all refer to the vertex, right? The vertex is always the highest or the lowest point, the maximum or the minimum point. So h equals negative 16t squared plus 12t, and there's no constant term, so I'm just going to put a plus 0 just because there's no c. Okay. And then the x coordinate of my vertex, right? So when they ask for a maximum, they are just asking for a vertex, right? So I just want to find the vertex of this parabola. So it's actually the t coordinate of my vertex, right? Because I'm using t's instead of x's for this problem. The t coordinate of my vertex is always negative b over 2a. And so that's going to be negative 12 over 2 times negative 16, which is negative 12 over negative 32, which is 3 over 8, right? 3 over 8. Yeah. 3 over 8, which simplifies to 0.125. I don't think that's right. I'll use a calculator. 0.375. Right, and that's a t value, which means it would be in seconds. So that is the time it takes for that rock that I threw to hit its maximum height. Right? So I know that after 3/8 of a second, my rock will be at its maximum height. How can I figure out what that maximum height is? How high is that rock after 3/8 of a second? Put that into the equation for h, right? Because h, all you do is plug in a t and it tells you the height of the rock. Okay? So the h coordinate of my vertex is negative 16 times 0.375 squared plus 12 times 0.375. I don't really need to write the plus 0 because plus 0 doesn't change anything. And then I'll just have a calculator do this. So 0.375 squared times 16 negative is negative 2.25 plus 12 times 0.375 is 4.5. And when you add those, you get positive 2.25. And what are the units on h? That is the maximum height. How are we measuring height in this problem? Yep, 2.25 watts. Feet. Yes, 2.25 feet. Okay, so we now know what the maximum height is and how long it takes to get there. And we should probably write that all out in a sentence to be really clear. Okay. The max height of the rock is 2.25 feet. And it gets there after 0.375 seconds. Okay? So anytime you see a word problem that asks for a maximum or a minimum or the biggest or the smallest or the highest or the lowest, those are code words for the vertex, right? Just find the vertex. All right, we'll do one more together just to remind you the 6-step process for graphing a parabola. Okay, so first thing we typically find is whether this thing opens up or down. How can we tell? By looking at A, in this case is 2, right? Okay, 1, A is 2. And because that's positive, that tells me that the parabola opens up like a smile. Yeah. Right, like that. Okay, now we look for the y-intercept and then the x-intercepts. So the y-intercept, for any kind of graph, in the whole range of things you can graph, to find y-intercepts, you make what 0? X. Good. So I'm just going to make all my x's 0, and then I figure out what y is. And that comes out to 0 plus 0 minus 5 is negative 5. So my y-intercept is actually 0, comma negative 5, right? We made the x 0, y came out to be negative 5. So plot that point. 3, to find x-intercepts, you make y 0. So I'm going to have change that y to a 0. And this becomes 2x squared plus x minus 5. And then hopefully I can factor it to solve. And if not, I would use the quadratic formula. I'll try to factor first. I'll just make a box. Okay, so I get 2x squared and negative 5. And then when you multiply them, you get 10x squared, negative 10x squared. So I need numbers that multiply together to make negative 10x squared and add together to make x. So factors of negative 10 would be 10 and 1, 5 and 2. Are there any others? No. And no matter what signs I put on these, I can't add them together and get 1, right? Yeah, so darn, this just doesn't factor. All right. So I got to use the quadratic formula. Okay, so the quadratic formula says that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then I plug in my values for a, b, and c. So I get, what is b in this case? 1. So I do negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 5 all over 2 times 2. Yep, it should just be 1 squared. Thank you. All right, so that comes out to negative 1 plus or minus the square root. So 1 squared is 1. Negative 4 times 2 times negative 5 is positive. Because negative times a negative makes a positive. Positive 40 all over 4. So this is negative 1 plus or minus radical 41 over 4. Is 41 a perfect square? No. Does it have any perfect square factors? Yeah, I don't think so, but maybe I just don't see them. So I'm going to check. The first perfect square number is, have them up around the board somewhere. Here we go. First perfect square factor is 4. So 41 divided by 4. Nope. The next one's 9. 41 divided by 9. Nope. 41 divided by 16. Nope. 41 divided by 25. Nope. 41 divided by 36. Nope. And then obviously 49 won't go in because it's bigger than 41, so it doesn't have any perfect square factors. So I just need to come up with some decimals for this so that I can graph my x-intercepts. So I would say approximately, actually, maybe I'll break it into 2 fractions because we've been doing that. Negative 1 over 4 plus or minus radical 41 over 4. So this will be approximately negative 0.25 plus or minus radical 41 over 4. So 41 square root it divided by 4, and I get like 1.6. The squiggly equal sign means approximately equal to. It means I just rounded those numbers. Okay. So now I just have to do the plus or the minus. So I have 0.25, negative 0.25 plus 1.6, and I get 1.35. Or then I have to do the minus. Negative 0.25 minus 1.6, negative 1.85. So those are my x-intercepts. So I'll plot them, 1.35 and negative 1.85. So you just do the best you can to estimate where they go. All right, so I know it opens up. I know the y-intercept and I know the x-intercepts. I've got those things all plotted. Next thing I need is the vertex. 4, yeah, 4. So I need the x-coordinate of the vertex. We can average the x-intercepts, right? Because I do have them. But I'm going to use our new method just to remind you, just use negative b over 2a. So b in this case was a 1, so I have negative 1 over 2 times a, so I get negative 1/4, or negative 0.25. So that is my axis of symmetry, and my vertex lies along it. So I'm going to graph that first. X equals negative 1/4, vertical line, my axis of symmetry. My vertex will be somewhere along that line. How do I figure out the y coordinate for the vertex? Yep, plug the 0.25 back into the original equation. Yep. The y coordinate of the vertex. I use my original equation, 2x squared plus x minus 5, and I plug in the negative 1/4 or the negative 0.25. So 2 times negative 0.25 squared plus x minus 5 plus negative 0.25 minus 5. Okay, so 0.25 squared. I didn't bother making it negative because I knew the answer would come out positive. And I get 0.0625, and then I'm going to double it, and I get 0.125. 0.125 minus 0.25 minus 5. And I get negative 5.125. So I've got my vertex, negative 1/4, negative 5.125. So I'm just going to go up to my graph. Along my axis of symmetry is my vertex, and it's at negative 5.125, like right there. It's tough to be real accurate with the decimals, but get the idea. All right, and then there's one more point. I can find the point symmetric to the y-intercept over the axis. So in this case, it would land like right over here to make a symmetric point. And then you just connect them all with a nice, smooth, U-shaped curve. It's just helpful to draw it more accurately. Yeah. And like on your quest, I asked you for it. So yeah. All right, so that's the first two from your activities from class 26. Okay, I'm going to have you work on the remainder of those activities until mm, 10 of, and then we'll start the next lesson. Okay, so we're going to look at lesson 27 for the remainder of class. Just want to remind you that your test a week from today, the next time I see you, is going to cover lessons 14 through 26, so not this lesson that we're about to do. Okay, this one will not be on the test. Okay, so in this lesson, we're going to begin our work with algebraic fractions or rational expressions, which means we're going to be able to simplify them, multiply them, and divide them. Okay, so these are just fractions that have x's in them. All the rules for adding, subtracting, multiplying, dividing, and simplifying are exactly the same as they are for numbers, fractions with just numbers. So here's some examples of algebraic fractions. 5 over x squared, x over x plus 2, x squared plus 5x plus 4 over x squared plus 6x plus 8. Okay. So they're just fractions that have x's in them, or some other variable maybe. So we could evaluate, we can simplify, we can perform operations with algebraic fractions, just like we do with ordinary fractions when you first learned arithmetic. So in arithmetic, you're often asked to simplify or reduce fractions to lowest terms. So here's just a little reminder of how you would reduce the fraction 24 over 54. You would ask yourself, okay, do 24 and 54 have any factors in common? Is there any number that goes into both 24 and 54? Yeah, 6. 6 goes into both. So I could rewrite 24 as 6 times 4, and I could rewrite 54 as 6 times 9. Right? They have a common factor, which means I can cancel the 6's. right? I could rewrite that as 6 over 6 times 4 over 9. 6 over 6 is just a 1, so it reduces to 4 over 9. Is everybody like, oh yeah, I've seen this before? Okay, all right, good. So we can cross off the 6's here, right? Because 6 over 6 is a fancy form of 1, right? So sometimes we call that a foo-foo for a fancy form of 1. All right, so let's look at number 4 here. Do we have a foo-foo in part A? Can I cancel the 2's? Yes, I can cancel the 2's. I like how you all like stopped and thought before you just yelled out an answer. That was good. Okay, yes, because the only operation here is multiplication, right? So if I really want to make this clear, I could rearrange it as 2 times 13 over 2 times 3. I could break it into 2, the product of 2 fractions, so 2 over, what is wrong with this? Changing the order of multiplication?
No, like canceling.
No, because multiplication and division happen in the same step. Yep. So right now I'm just changing the order on the top and the order on the bottom, right? And then this could be 2 over 2 times 13 over 2. I don't know what is wrong with this. I'll write it on the other side. 2 over 2 times 13 over 2. Because 13 over 3. Thank you. Right, because the rules for multiplying fractions are you just multiply the tops and you multiply the bottoms, right? So this would become 2 times 13 over 2 times 3. And then 2 over 2 is a fancy form of 1 and it cancels. So we could, at the very beginning, just cancel the 2's. That's allowed. All right, how about with part B? Can I cancel the 2's? Yes, no, I don't know. All right, so let's see. If I actually just do the arithmetic, right? Like Abby mentioned earlier, the order of operations, you have to do the top and the bottom of the fraction first. So this becomes 15 over 5, which reduces to 3. Good. All right, so that equals 3. If I just canceled the 2's, it would look like my answer is 13/3, right? But that's not right. So I can't cancel the 2's in this case. So this one is a big no. Right? So I could do the same little check on the first one. That's helpful, right? 13 times 2 over 2 times 3, just multiply the tops, multiply the bottoms. 26 over 6, that would reduce to 13/3, right? 13/3. So I could have just canceled the 2's from the outset. How about in C? Can I cancel the 2's? No, right? Because let's just see again. If I do the actual arithmetic, 13 minus 2 is 11. 2 minus 3 is -1, so I get -11. If I cancel the 2's, I get -13/3, right? So I can't do that. So this one's a no also. This one was a yes. Okay. So in general, the way you can tell if you're allowed to cancel is if the operation that's separating your numbers is multiplication, right? You can cancel when the only operation is multiplication. Okay, so in part A, I had 13 times 2 and over 2 times 3. You can cancel the 2's because it's multiplication. In B and C, I had other operations. In B, I had addition, and in C, I had subtraction. Canceling doesn't work unless you're dealing with multiplication. All right, so a foo-foo, a fancy form of 1. If you want to simplify or reduce an algebraic fraction, just like with regular arithmetic fractions, you look for a common factor in the numerator and the denominator. So that word factor, right? We've been working on factoring for a couple of weeks now, right? So you want to factor the numerator, factor the denominator, and see if they have any factors in common that you can cancel. All right. So, big question, are the numerator and denominator in factored form? If the answer is no, then you cannot reduce it until it's factored. So, x squared minus 9, is that in factored form or can I factor it further? It can factor it further. And the same with the denominator, I could factor it further. So are they in factored form? No. So I factor. Okay. X squared minus 9. Can anybody factor it quickly? X plus 3, x minus 3. Let me do out a box just to make sure that everybody's on the same page here. Although you don't actually need a box, this is a special case we learned about because it's the difference of two squares. But you can do it with a box. Do it quickly over here. So I've got my x squared, I've got my minus 9, and I have negative 9x squared. No, why would it be plus 9?
Oh, you're looking at the top one.
Oh yeah, I'm just looking at the top one, yeah. So now I want numbers that multiply to make negative 9x squared, but add up to make what? 0, because there's no x term. There's a 0x in the middle there. Okay, so I could use 3x and negative 3x. Right? They multiply to negative 9x squared, but they add to 0. 3x, negative 3x. So look at the first row, pull out the GCF. You pull out an x. X times x is x squared, and x times 3 is 3x. And x times negative 3 is negative 3x. So you have x plus 3x minus 3. All right, for the bottom, how does that factor? Anybody have it done already? X plus 3, x plus 3. Great. X plus 3, x plus 3. Okay. Now, I have everything factored completely. Do I have a foo-foo? Do I have any identical factors on the top and the bottom? I've got an x plus 3 on the top and an x plus 3 on the bottom. When you put one thing over itself, that is 1, right? That's a fancy form of 1. So I cancel them, and then my final reduced fraction is going to be x minus 3 over x plus 3. That's the answer. Yep. Good question. Can these x's cancel? Right, no, because they're separated by addition or subtraction, not multiplication. All right, that's good. We'll look at a couple more. So the big question, are the numerator and denominator in factored form? 3x plus 12 or 6x plus 24, can either of those be factored a little more? Yes, they both have GCFs, right? So the big question is no, they're not in factored form. So we factor them. 3x and 12, what do they have as a common factor? 3. So I pull out a 3, and I'm left with x plus 4. 6x plus 24, they have a common factor of 6. And that leaves me with x plus 4. Do I have a foo-foo? Yeah, there's x plus 4 on the top and the bottom, so I cancel them. And I'm left with 3 over 6, right? But that reduces to 1/2. All right, and another one. 2 plus x or 2. Can either of those be factored any further? No. 2 plus x does not, 2 and x don't have any common factors. 2 is just a single number. It can't be factored any further. So my answer to the big question is yes, right? They are already both completely factored, right? Which means we're done. That is already in reduced form. You cannot cross out the 2's, right? Because the 2 on the top is separated from the thing next to it by a plus, not multiplication, right? So the final answer is just 2 plus x over 2. Can't reduce it.
So would you write irreducible?
That would be fine, or you could just say 2 plus x over 2. Irreducible is fine. Okay, so here's like kind of a tricky one. X minus 3 over 3 minus x. Are the numerator and the denominator exactly the same? No, they look a little bit different, right? The subtraction order has changed. Okay, so my question, I'm like, they're almost the same though. So let's see what happens if I put in two different values for x. Like what if I put in x equals 10 here? So I have 10 minus 3 over 3 minus 10. That becomes 7 over 3 minus 10 is negative 7. What's 7 divided by negative 7? Negative 1. Good. Okay. So what if I put a different value in for x, like negative 2? So I could put in negative 2 minus 3 over 3 minus negative 2. What is negative 2 minus 3? Negative 5. What is 3 minus negative 2? 5. What's negative 5 over 5? Negative 1. Yeah. So I plugged in two different x values, and I got negative 1 both times. Do you think that's always going to happen? Well, let's try one more. Somebody give me a random x value. 6. Okay. All right. So if I do 6 minus 3 over 3 minus 6. 6 minus 3 is 3. 3 minus 6 is negative 3. 3 over negative 3 is negative 1. 14. What if I do 14 minus 3 over 3 minus 14? 14 minus 3 is 11. 3 minus 14 is negative 11. So I get negative 1. Convinced yet? Yeah. So we did all even numbers. Ooh, okay. Let's try an odd. That is great. Okay, let's try 1. So if I do 1 minus 3 over 3 minus 1, 1 minus 3 is negative 2. 3 minus 1 is 2. Negative 2 divided by 2 is negative 1. Yep. So we did test some positives and some negative numbers because we did the negative 2. We did some evens and an odd number. All of it came out to negative 1. So it turns out this is always true. If you have a fraction a minus b over b minus a, right, you just reversed the order of the subtraction, it always cancels to negative 1. Always will reduce to negative 1. A negative number. Oh, yeah, we could try that. So you want to do one more test? That's fine. Negative 1 minus 3, right, over 3 minus negative 1. Negative 1 minus 3 is negative 4. 3 minus negative 1 is 4. Negative 1. Always going to be negative 1. You can just automatically write negative 1. Yeah. And we're going to do an example where we do that. Yeah. So so I'm going to start with 64 minus x squared over x squared minus 6x minus 16. All right, and I'm not going to go through how you get all the factoring, just to save us a little bit of time. But 64 minus x squared factors to 8 minus x times 8 plus x. And x squared minus 6x minus 16 can factor to x plus 2 times x minus 8. Now, none of my factors on the top and the bottom are exactly the same, right? I don't have any foo-foos, fancy forms of 1. I don't have any exact factors. But on the top, I have an 8 minus x, and on the bottom, I have an x minus 8, right? 8 minus x and an x minus 8. I just reversed the order of the subtraction. So those two cancel to be negative 1, right? Just like our example up above, right? Where I had 3 minus x and x minus 3. Now I have 8s, x minus 8 and 8 minus x. Okay, so those are always going to reduce to -1. Okay, so we replace one of them, but not both of them, with a -1. So this becomes those circled factors reduced to a -1. So that -1 comes from the circled factors reducing. And then I still have 8 plus x over x plus 2. And then that's my final answer, -8 plus x over x plus 2. All right. Can we cancel anything here? X plus 5 times x minus 1 over x minus 7 times 1 plus x. No, there are no identical factors, right? And if I was going to use that other rule, the a minus b over b minus a, if I had an x minus 1 here, what would have to be on the bottom to be able to cancel? 1 minus x would have to be the thing on the bottom to make a -1. But it's not a 1 minus x, it's a 1 plus x, so nothing cancels. Okay. All right, let's look at number 10 here. So multiplying and dividing algebraic fractions works exactly the same as multiplying and dividing regular numeric fractions. So how do you divide two fractions again? Somebody remind me. Ooh, no. And multiply. Yes, you multiply by the reciprocal of the second fraction. So instead of dividing by 2 over 27, I'm going to multiply by 27 over 2. You can, and you can also reduce the 9 and the 27 before you continue to multiply. So 4 and 2, those reduce because you can say, okay, well, 2 goes into 2 one time and it goes into 4 2 times. And then let's look at 9 and 27. How many times does 9 go into 9? Once. So I cross that out and put a 1. How many times does 9 go into 27? 3. All right, so then that becomes 6 over 1, or just 6. You also can multiply before you reduce. It's totally your personal preference, right? You could have started with 4 over 9 times 27 over 2. 4 times 27, 98 over 18, right? And then you could try to reduce those. Right? You could say, are there any factors that go into both 98 and 18? 2 for sure, yeah. 4 times 27 is 108, thank you. Yeah. 108, thanks. 18 goes into both of them. Yeah. Yeah. 18 goes into both of them. Yeah, 9 goes into both of them too, but 18 does. Yeah, so I could rewrite this as 108 is 6 times 18. 18 is 1 times 18. Fancy form of 1, you get 6. So you can either reduce before or after you do the arithmetic. It's up to you. When the numbers are big, it's often easier to reduce before. Okay, so now I'm going to do a couple of arithmetic problems where I have x's and y's. I have some unknowns or variables in my expression. Okay, so I'm going to find the product or quotient and simplify, just like I did with the numbers. So 15, x to the 9th, y cubed. I could write that as over 1. You can put anything over 1, and that makes it look like a fraction. And then times 2 over 35, x to the 4th, y to the 10th. General rule for multiplying fractions, multiply the tops and multiply the bottoms. So I can multiply my numbers. 15 times 2 is 30. And then I just have x to the 9th y cubed. And then 1 times anything is just that thing, 35 x to the 4th y to the 10th. And now I have to remember all those exponent rules to simplify it, right? So let's start by simplifying the numbers. 30 over 35. 6/7, yeah, because 5 goes into both 30 and 35. So 6 over 7. Okay, x to the 9th over x to the 4th, right? When you're dividing like bases, you would subtract the exponents. So I end up with an x to the 5th. And where should I put it, on the top or the bottom? The top. Yeah, you put it where the larger exponent was. Y cubed over y to the 10th. Like bases, you subtract the exponents. Y to the 7th on the bottom. Yeah. Good. All right, last one, and then you can do some practice. So this time I've got two fractions and I'm dividing them, so I have to use my flip and multiply rule. So I have 4y squared minus 1 over 4 minus y squared, and then I'm going to multiply by the flip of my second fraction. Y squared minus 2y over 4y plus 2. Okay. Now, before I start trying to multiply things, I think I'm going to factor everything as much as I can. That way I can do some canceling before I multiply. It will make my life easier to do that. So 4y squared minus 1. 4y squared is a square, and 1 is a square. They're both perfect squares. So that's going to factor to 2y minus 1, 2y plus 1. 4 minus y squared. Again, that's a difference of two squares. So it should factor to 2 minus y, 2 plus y. Y squared minus 2y, do they have any factors in common? Y, factor out a y. And I'm left with y minus 2. 4y plus 2, do they have any factors in common? Two. Pull out a 2. And I'm left with y plus, 2y. 2y plus 1. All right, do I have any exact factors that can cancel? Exactly the same on the top and the bottom. Not in each fraction separately. So let's multiply them together. So when you multiply fractions, you just multiply the tops and you multiply the bottoms, right? So this is going to be 2y minus 1, 2y plus 1, y minus 2. So we didn't actually do the multiplication, but I just wrote out, multiply all these together. Put that all over all of the bottom stuff multiplied together. 2 minus y, 2 plus y, 2, and 2y plus 1. All right. Now, do I have any foo-foos? 2y plus 1 appears on the top and the bottom. So I can cancel that one. Okay. Do I have any other foo-foos? Nothing else identical. Do I have any of those special a minus b over b minus a's? The y minus 2, the y minus 2, and which other one? The 2 minus y. Just, you have to look for the subtraction order to have changed. So y minus 2 and 2 minus y. So those two, they reduce to a negative 1. Okay. No, just in one spot or out front, on the top or on the bottom or out front. I'm going to put it out front. I think that's the least likely way to make a mistake. All right, then nothing else is exactly the same or opposite subtractions, right? So I'm going to put a negative out front to account for the y minus 2 and 2 minus y. And then I'm going to copy what's left. 2y minus 1 times y is left on top. And on the bottom, I have 2 plus y times 2. And the circled factors reduced to the negative 1, so that became a negative sign out front. That's the answer. Yep. Oh, there'd be personal preference. Yeah. Sure, yeah, we could go one step further if you want and do 2y squared minus y over 4 plus 2y. It should take either one, unless it specifies leave your answer in factored form, in which case it would want the first one, right? Or multiply your answer out, in which case it would want the second one. They are both reduced form. The factored form is the first one, right? Because the numerator and denominator are both factored.
So the answer on the right is factored.
No, the second one, the one on the right is not factored at all. It would be multiplied out, multiplied together.
I just want to know what we're calling that. So
Mm-hmm.
we need to put
Yeah.
areas.
So
They're
this,
all different between homework.
so this one is called factored form. And this one's called multiply, we just multiplied it out. I'm fairly certain my math lab will accept either of those answers. Put in whichever one you want.